Okay, so sample. So let me make sure that I'm making sense for you what we're doing right now. We're taking samples to figure out something about a true number, right? Just like polling, like what they do before an election. That'll happen in a year, and they'll go crazy with polls like they always do. We'll get sick of seeing them online like every day the month before the election. And so what they do, that's a perfect example for statistics. So they ask 100 people who they're going to vote for, and they try to use that information to predict what's going to happen in the actual election. And they might say, we think 52% are going to vote for candidate A in the election, but there's an error there, give or take 3%, because they know their little sample of 100 could have been weird in some way, not representative of the whole United States population. Maybe those were rich people, poor people, old people, young people, whatever people that have different voting tendencies than the United States as a whole. So that's why we have that error margin. They call it the error margin, right? Well, we know that if, what could you do if you want, what they want is they want less error margin, don't they? They'd like to be able to make a more, if I said to you, hey, I think I know how the election's going to go, 53% are going to vote for candidate A, give or take 40%. Give or take 40% error. What do you think about that statement? Give or take 40% error. What am I saying? I'm saying it could go from 53 minus 40, right? To 53 plus 40. In other words, it could go from 13% to 93%. So I'm saying, you know what? I think that on election day, somewhere between 13% and 93% of the whole population is going to vote for candidate A. I'm not saying much, am I? I mean, probably a 5-year-old could predict that, right? Sure, it's going to be somewhere between 13 and 93. That's not saying much. So why? Because the error's so big, huh? So we'd like to make the error smaller. When the error is smaller, we're actually saying something more significant, something more narrow, right? If instead of a 40% error, it was 53% plus or minus 2%, well, then that would be from what? 51 to 55%. Now you're really saying something. Now you're saying, I'm pretty sure, 90% confident, that on election day, on the actual election day, somewhere between 51 and 55% of the United States population is going to vote for that candidate. That's a strong prediction. Whether it's right or not, time will tell. But that now you're saying something. So we'd like to make the error margin as small as possible. What do you think we could do to make the error margin, not be a whopping 40% and make it smaller? Should we ask more people or less people in our sample? What will make less error more confidence? How about? More people, huh? Yeah, you all sense that. The more people you ask, the more sure you are. Just like with the medical treatment example, right? I gave the example, and I said the old medical treatment cured whatever it was, 70%. And I said, then we have a new treatment, and 8 out of 10 get cured, which is 80%. But the problem is we only did 10 people, huh? So we wouldn't have very much confidence. There would be a huge error that goes with that. And so we really need to ask more people than just 10, or give the new treatment to more people than just 10, so that we can have more confidence and make a more narrow statement. Basically have less error. So we all feel that more people means lower or less error margin, right? It means a more narrow error margin. It raises our confidence. Well, exactly how many more people? Well, that's what this section is all about. It's helping you calculate how many people you need. So let me go to a fresh screen now that I scribbled all over that one. Let me go here. Okay, so let's read the actual question. A political candidate has asked you to conduct a poll to determine what percentage of people support her. If the candidate only wants a 5% margin of error at a 95% confidence level, what size of sample is needed. So now with this section, we're going to actually be able to figure out what kind of sample size you need. So you see what they want. They want they want to be 95% confident, 95% sure, and they want the error margin to only be 5%, give or take 5%. They want to be within 5% either way of the real. They want to be 95% sure that they're within 5% of what is really going to happen on election day. So how many people do you need to talk to get that kind of confidence? And you all feel it. The more people you talk to, the less chance that random luck is going to throw it way off, huh? So how many people? Well, there's all kinds of formulas for that. Okay, so here's how we do it. And that's just the beginning. We're going to have other formulas for different kinds. So let me put it right here for you. So sample size. Notice my note at the top. Always round up. Always round up. Even like 88.1 goes to 88.1 goes to 89. Always up. Okay, and then I'm giving the example A, and I'm saying if you have a P or a percent, that's what we have, P or percent. And case 1 is the sample P is unknown. I'll explain all that. It'll be easy to tell. Sample P is unknown. That's our situation. Then N is going to equal the number that you need in your sample, Z squared times 0.25 over E squared, where E is the error. And Z, like what's this Z thing? The Z equals inverse norm, parenthesis, and then another parenthesis, 1.0 minus the confidence level given, divided by 2, 0, 1, and then the outer parenthesis. All right, all of that. So let's give it a try on this particular problem. Let's go back here. So I'm going to actually do it. So they're telling me 95% confidence interval, error 5%. Okay, so here comes the formula. It's going to be N equals, and it's Z squared. Now what is the Z? How do I get the Z? It's inverse norm. Inverse norm, parenthesis, and then inner parenthesis, 1.0 minus, and see how it says confidence? What do you think I'm going to put in for confidence? This as a decimal, huh? Make that a 0.95. Divided by 2, 0, 1. And then close the parenthesis. Squared, right? Because that Z, this is Z, is supposed to be squared. You tracking with me? I'm doing the Z, it's supposed to be a Z there. I'm doing the Z squared times 0.25 over E squared. So there's the squared. So the inverse norm, Roberto.
If your question has 97.5 confidence level, you put that in parentheses, how would that?
It'd be right here. This would be 0.975. Okay. Good question. Yeah, so whatever percentage they give you, just move the decimal back 2 places and pop it in right there. Is that making sense on that? So just change it to a decimal and pop it in right behind a 1. Now why that works is, well, we'll talk about it later. So we got the Z squared. And then next comes the 0.25. 0.25. All over, you can just go divided by. Or all over, whatever. Divide by, all over, whatever. The error squared. And what's the error? Well, they told us right there. They want a 5% margin of error. So that would be 0.05. Got to change that to decimal too. Got to change all those percentages to decimal. That's 5% squared, right? The error is squared on the bottom. So divide by 0.05 squared. I got n equals 384.1, and remember we round it to 385. Round to 385. Helps. This parenthesis one. Well, yeah, no, I think it's all good. I'll just leave it. So make sure you're doing the two parentheses when you begin the part right there.